Even and odd functions. By definition, an even function is a function for which f of the input negative x is the same expression as the f of the x. Basically, when you replace the input with the negative x, it returns the same expression as the original function. And it works for all of the x values in the domain of the function f of x. And the graph of an even function is symmetric about the y-axis. As you think about the xy plane, and the order pair, here is the order pair x comma y. If you replace x with a negative x, it will return the same function value. So that means the graph is reflecting about the y-axis. For the odd function, the odd function is the function for which if you replace the input with the negative x, it will return totally opposite of the original function value as the function of f, the function f of the x for all of the x in the domain of the function. And then the graph of an odd function is symmetric about the origin. With the diagram for the graph in the xy plane, if you look at the order pair x comma y, you replace the x with a negative x, but it turns out to be the function value that totally opposite of the original. Therefore, you would get the point that in the opposite quadrant, which is negative x, negative y. If the point xy in quadrant number 1, the odd function will have the reflection at the quadrant opposite to the original quadrant. So xy is reflected about the origin to be the point negative x negative y. So that what it means by an odd function is symmetric about the origin. For the algebraic function, to determine whether the function is odd or even function, we start with the same procedure. Replace the x with a negative x. Let's see if it turns out to be exactly the same as the original function. So this case, the function is an even. If it turns out to be totally opposite of the original function, this function is an odd function. If neither of them is not equal to f of x, nor equal to the negative of f of x. So this case, we call it neither. The first example, f of x is x to the fourth plus 3x to the second plus 1 is an even function because if you replace x with a negative x to the fourth plus 3 times negative x to the power second plus 1 and simplify to get x to the fourth plus 3 times x to the second plus 1, that turns out to be exactly the same as the original function provided. So we can wrap it up as f of negative x equals the f of x. That's why it is an even function. The second example, we treat the same way, starting with replacing x with the negative x. So negative x to the third power plus negative x simplified to be negative x to the third because negative x quantity to the power 3 means you multiply negative x 3 times and then return to be negative of the x to the power 3. And then the second term is negative x. As you see these two terms, they are totally opposite of the original expression of the function f of x. In this case, we can summarize as f of negative x is negative of the function f of x. And therefore, this one is an odd function. Where the last example, the f of x is in the form of x to the third plus x to the second. If we replace x with a negative x to the third power plus negative x to the second power, simplify to be negative x to the third plus x squared. It's not exactly the same as the original function, also not exactly the same as totally opposite of original function. So this case, we call neither an even nor odd function.